I'm here to talk to you about visual testing, and specifically visual testing UI components. We'll talk about why visual testing helps you ship better looking products, and what tools are needed, and how it all fits into a development process. So a little bit about me. I'm a product designer and founder at Chroma, and we build a UI testing tool called Chromatic. It's a tool that helps developers find UI bugs automatically. So I feel like I'm pretty well qualified to give this talk. Previously, I designed developer experiences at Meteor.js and Apollo. If you used one of those projects, you probably touched something I've built. A decade of building UIs and building apps. Something that I realized is that I always kept on hitting the same problem. And the problem is getting asked the question, does this look right? Again, and again, and again, and again. Just to articulate the problem, it's that the user interfaces, and specifically testing them, has always been tricky. The details of design are subjective. Does this shadow look right? And nuanced, is that button a pixel off or 2 pixels off? And the thing is, it's still easiest to verify whether something looks right just by looking at it with your eyes. But it's really hard for a computer to compute that same verification. So apps are complex. They're more multi-state and they're more personalized than ever before. And this ends up yielding thousands of permutations. The complexity is dealt with in Vue and in all the other modern UI frameworks with these things called components. And what that does is that they essentially modularize the actual building of UIs. And modularization helps you test and kind of confine some of that UI logic. And so what we're seeing is more components, just in general in your apps. And if you're building an app today, you probably have tens, hundreds of components. And you're seeing increased, and we are seeing increased complexity in every one of those components. So this makes like the old eyeball test to kind of verify that something looks right pretty impractical, because if you just do multiplication, it's thousands of states that someone has to look at. No one's going to do that. So most teams can't afford full UI test coverage, so they end up enduring the inevitable bugs that comes out of that. If you build software for a living like me, you've probably fixed like countless bugs, and you spent thousands and thousands of hours on these bugs. What is it, like 10,000 hours makes you an expert? I feel like I've definitely reached that point by now. And most often, what happens is that these minor tweaks snowball into these major regressions, especially in componentized systems where you have a hierarchy and the small components kind of like ripple outwards. Small components that are used often, the changes ripple outwards to everywhere they're used. And with teams using CI and building like these heavier front ends, pinpointing UI regressions is just harder than ever. So you might look to automate it. So you probably already automate a lot of other tests in your app. Unit tests, end-to-end tests, just ways to kind of have a computer do the labor and the hard lifting of testing. So why can't those same ideas apply to UI too? So let's just recap the types of testing solutions, and we'll find out why they don't necessarily make sense for UI. So unit testing tests the functional properties of a piece of code. What you do is you specify an input, run it through a module, and measure the output. They're useful if you want to verify something concrete, 2 + 2 = 4. The problem with unit tests is the output of a function doesn't actually capture the look of a component. Snapshot tests complement unit tests. The main difference is that they capture the generated markup, the HTML, if you will, of your component. Now, you can identify if the markup is changed using a snapshot test, but again, it doesn't actually tell you whether or not a layout is shifted or something has changed colors or anything like that. With reliability, that is. And screenshot tests involve taking a screenshot of UI and comparing them pixel by pixel to figure out if things have changed. They're useful for quickly comparing two screens based on a given route, but they return a lot of false positives, which you then have to manually sort through as a developer. End-to-end tests simulate a user walking through the core flows in your app. They're great for telling you if a flow is broken or is changed, but not if like a button is like kind of like shifted off screen a little bit, or an image is even visible. So the existing solutions just aren't that suited for testing the appearance of applications these days. They're mostly intended for code, not the rendered UI. Verifying the appearance of UI should actually then test the rendered UI, what the user is actually going to see. So let's look at a different approach that achieves the coverage of the automation of those previous tests, but also the accuracy of of manual testing, which is just looking at it with your eyeballs. So Vue centers on components. The pattern provides a well-scoped and modular way of building and testing UI. We can focus on testing these same UI components, these essential building blocks of applications. And if we do that, it's possible to get this great coverage and this accuracy in testing with a lot less work. So what is visual testing? Visual testing involves defining the states of a component, then verifying that it renders as expected during testing. It focuses the manual testers, you and me, only on the exact states, the exact component states that require our attention. This means that you can quickly and easily run a manual visual test of a component's important states and see how it looks and decide if it's rendered properly. So you're already building the UI components. You have to do it as part of your job. So why don't you use the same props to test as well? In practice, visual testing ends up being a lot easier than sifting through the false positives of other automated testing solutions and working overtime to make all the tests green again. It also is much less work than hunting down UI regressions after the fact. Maybe sometimes days, sometimes weeks after the fact. So what tool do you need? What tools do you need? The core tool that you're gonna want to use is called the Component Explorer. For those of you who don't know what Storybook is, it's a tool that allows you to work on components in isolation. You can kind of think about it as like a component development environment. And visual testing relies on this tool of using a Component Explorer to simulate component states during the build-out and play them back again during testing. So a Component Explorer lives alongside your app in development mode. It doesn't get shipped to production. It's just a tool for developers to build components. You can think of it as just like an integrated development environment for a component to build and test UI components. Writing tests is as simple as getting your component to render in a certain state in a Component Explorer. So, for instance, if you're building a button component or a date picker component, it's just like the primary state or the empty state or all of these states you end up having to build for components anyways. You render them in a Component Explorer and by passing a combination of props. And that allows you to build it easier, but also allows you to test it easier. Companies of all shapes and sizes already use component explorers. The most popular with developers is Storybook. But there's also VuePlay, which I think is based on Storybook. And I don't know if it's currently in development. But it doesn't matter if you're one developer or hundreds. The component explorers are pretty simple to maintain and simple to set up and easy to maintain. So what does this all look like? Let's put it all together and create a visual test using a component explorer. So here we have a comment list. Again, a visual test is simply defining the component states and then rendering them in a component explorer. And this allows you to confirm that the exact states of your component look as they should during testing. So since this is a demo, I'm going to walk through the code steps, but I'm going to skip live coding because I've been known to mistype. So yeah, let's make a new component. First, you install the view. You create a new component called comment list. And then you get Storybook. Next, we'll build the simplest possible component list implementation, just to ensure that our tests are set up right. So here we have a loading state, an empty state, and a has data state. Something exists. In a separate file, or maybe the same one, we'll add our tests. We've added a few states that we want to look at. And as you can see, we define the state names and pass props that render pass props to the component that it needs to render those states. And we've also mocked a few comments to fill out the test, sure, in the ellipses there. Now, let's go to Storybook to confirm that the states are actually showing up as they should. Here they are. Again, we built the simplest possible implementation just to get it into the Component Explorer. Next, we'll flesh it out. In this case, we'll focus on the has data state. In the, so on the left column, you see the template that you saw before, and on the right, you see a little bit of logic to generate those states. And then we have the styling. In this case, I generally use CSS and JS, but you can pretty much do whatever you want. Any styling pattern will work. Finally, we check the implementation against the design. So you can see that has data is rendering fine. And if we toggle through, we can quickly check the appearance of the other states to prevent regressions. And if we're happy with our has data implementation, we just move on to creating the next state and the next state and the next state. And at the end of this, you have not only your full component, your full functional stateless UI component, but also the corresponding tests used to render those specific states. And if you do this a few times, all of a sudden you have an app too. Just to gloss over it. So visual testing has some distinct advantages. First, it's accurate because you're using a human to QA whether a component looks right in a certain state. And the coverage is better because you've actually explicitly specified all the states that a component is expected to support. So there's no ambiguity there on what does this look right for a component. And best of all, the states are documented in your Component Explorer, so you can continue to check on them as your apps and your needs evolve. So visual testing ends up being a pretty easy way to prevent UI component regressions. But there's one more thing. As you know, apps are constantly changing. And if you've worked on a team of any size, you'll probably find out that UI bugs are kind of a fact of life. And the real challenge, the real meta game at working in a company is that you have to find the UI bugs before they hit production, before your users do. So what can you do? If we combine visual testing and the screenshot testing that I had mentioned earlier on, you can kind of automate the hard parts of visual testing, or like the most expensive parts of visual testing, and while still getting a lot of the benefits. So screenshot testing, again, involves taking pictures of rendered UI and comparing them to catch changes. As I said earlier, they're prone to false positives at the screen level, but if you direct them at components that have visual tests, you can get the best of both worlds, because you're directing the screenshot tests only at the things that you've explicitly decided to care about, the states that you've decided to care about. All right, so visual tests give you a way to define and verify component states using a component explorer. It's hard to tell when what's on the screen. So when a UI component is updated, it's easy to confirm how those changes affect each state. And screenshot tests are great at telling you when changes occur. And so when you combine screenshot and visual tests, you're able to automatically pinpoint regressions across your entire component library, down to the exact component and state. This takes advantage of the coverage and the reliability of automation, and helps focus the manual tester on the things that matter. So here's what it looks like in a development process. First, you update a UI component. Next, you take snapshots and compare the UI component, compare the new version to the previous version. If things have changed, you get a chance to accept or deny those changes. And once you accept all of the changes, that they are in fact intentional, then you merge and deploy as you normally would. So how do you actually go and build such a tool? Building visual snapshot testing involves gluing together a component explorer that we talked about earlier, and one of the many screenshotting libraries that allow you to take screenshots on your development machine. Here, just to name them, Backstop, and Puppeteer, and Visual Review, and I think that's Chromatic or something. Again, there are open source libraries for all of this. But if you would prefer to have an out-of-the-box solution, what my team works on is a tool called Chromatic, which hooks into your GitHub, your code hosting service, and your CI service to do it all seamlessly out of the box. And by the way, usage is free and unlimited for the next few months. We're previewing the service to a lot of companies right now. To recap, visual testing gives you the confidence in shipping UI. And if you want to learn more about what I talked about today, you can check out a free handbook that I co-authored. There will be a link to download it at the end as well. Again, here are the links. Download the book if you're interested in visual testing components. If you're interested in trying out a visual testing service for Vue, just go to chromaticqa.com/vue. Any questions? So your question is, where does the component explorer live in the process? And how does snapshot testing, how does testing fit into the CI thing? And yeah, I could be clear on that in the presentation, definitely. So the component explorer, there are two valuable places that the component explorer lives. The first is that it helps you build out the components, going from 0 to 1, right? And the reason why it helps you build those out is you can build a component in isolation. You can mock the properties that you end up using in production. And so that allows you to see the permutations that your app ends up supporting, that your component should support. So think about a button or a date picker. A button could have a primary, a disabled, a secondary, like a tertiary state. And those all correspond with different properties. Component Explorer helps you visualize all those properties in an isolated way, or all the states in an isolated way. Now, that's the 0 to 1 like build out process, right? For the testing, when it comes to testing, what you built out, you essentially built out tests using Component Explorer, and that helps you go from 0 to 1, but it also helps you QA that the button looked the same afterwards. You can go back to the states that you made and just visually like verify them. So that's the building and testing part. Now, your other question was, how does snapshotting and how does visual snapshot testing fit into the CI process? So the way that we have it working, and the way that I've seen it in a lot of organizations, is it's just similar to your unit tests, similar to your end-to-end tests. It gets hooked. It's all packaged together into like a CI config, and your CI is responsible for firing off all of those tests and determining whether or not to either deploy or not deploy, depending on the results of whether those tests pass or fail. And so, yeah, did that answer your question?
It did. Can I have one follow-up?
Sure.
Just for practical reasons, like, so if you're studious about writing unit tests, regression tests, etc., you probably have already a long test suite. How have you guys dealt with the extra overhead that snapshots testing adds?
The external. So, I want to clarify what I specifically mean by visual snapshot testing versus what snapshot testing is. So snapshot testing is it takes a snapshot of the rendered, not the rendered, the markup and the styling that gets outputted from a component. Visual snapshot testing takes just a picture of the rendered UI. So that's a distinct difference that just wanted to highlight. And yeah, the way that visual snapshot testing, or that we've found visual snapshot testing to work is in a CI environment is you set it up, you configure it with your in-circle or what service you use, and you essentially like get every single time you commit code, you get a visual diffs of every single component. When those visual diffs, or when things have changed, your team gets an opportunity to review those changes. If you approve all the changes, you pass the test pass, and it moves on, and you can deploy from there if you want to.